Yeah. Okay. In today's session, I will be walking you through all the aspects in terms of like in the cost. When it comes to cost optimization, there are multiple locations where you can do the cost optimization, like networking, the optimization of the VMs and all. Today we will be focusing on the networking first, because that is a bare bone of your any of the infrastructure. Okay, and then later sessions will be covering the infrastructure cost reduction part and all. Okay, and how to choose what kind of VMs you need or whatever. So that will be covering in the subsequent sessions. Okay, so today mostly we'll be talking about the network related cost optimization. Okay, and these changes not only just help you with the cost related optimization, but also when it comes to network latency and other things, they will help, these concepts will help. Okay, so I will be walking you through. Uh, are you able to view my screen?
Yes.
Okay. So I will be walking you through the console directly, so it would be very easy for you. I'm gonna show you in AWS only. The same concept you can check in Azure console or GCP console. It's based on the basic concept will be similar for all. Okay, because VPC is there in all the like VPC, VNet. The name might be different, but the core service would be the same. Okay, like NAT gateway is there, so NAT gateway in GCP might be something else, but NAT gateway is something which help you to communicate outside world when your infrastructure is in private subnet like that. Okay, so I'm just giving you the brief of your like when it comes to the networking part. Okay, and you can apply the same in any of the environment. Okay, or cloud. Okay, so let's suppose I'm just going to create an VPC. Okay, and the VPC I'm just using the console. I want two subnet, three subnet. Let's go with the three subnet. Uh, Number of public subnet 3, private subnet 3. I am going to create this one. Uh, yeah, yeah. So you can see I'm going with a very basic configuration of any VPC. Okay, and the VPC is a simple VPC where each subnet has one public and one private subnet. And I'm also going to create one NAT gateway so that my private subnet can communicate to the resources in the private subnet can communicate to outside world. Okay, so I just the console and it's very easy to navigate. Okay, so
सर
I
थोड़ा
just
zoom कर लेंगे सर.
just is it good now?
Yeah. For me, it's good because obviously I have a very ultra short.
Yeah.
Others may not be able to see. Yeah.
Okay. So you can see the create VPC is like I just created a navigation wizard. Okay, I'm not going you to what is VPC and subnet, but I'm just creating a VPC. So most of you, I guess, know the VPC is the where one when you to create a like you if you want to provision in any resource in AWS which is needs any ENI or kind of things. ENI is nothing but network interface. Okay, so you need the VPC. Okay, so then we created a we are going to create a subnet. We are going to create a VPC of /64. Okay, then here I decide like I am going with like all three AGs present in Mumbai region. Okay, and I need three public subnet, each in each AZ. Same goes for private subnet, each private in each AZ. Okay, and one public because public is nothing but making it like all the resources can communicate to any of the public until unless there is a firewall or security level blockers. But if talks about routing, it's a very simple routing. All 0.0.0 will going to internet gateway. Okay, so you can see it's going to internet gateway. In private, we can have a single route or different route for each private subnet. It's up to the requirement. Because I'm going through this console, which auto creates it. So it's going to create each routing table for each private subnet. Okay. So it's up to the requirement of how you want to create. Okay. So there is no charges. It depends on how you want, like what kind of maintenance you need on, or what kind of a difference you want to make in these two private subnet itself. Okay. And then if these private subnets wants to like any resources which is in this private subnet, so one NAT gateway is going to create. Okay. So I'm just going to create it. This VPC. So as NAT gateway takes some time to activate, let's wait for it. In the meantime, you can see VPC is up. All 6 subnets are there. One in each AZ. Sorry, 2 in each AZ based on public and private. One public route table is created. Private route table has to be created based on this NAT gateways get provision. Once the NAT gateway is provisioned, the route table will be added for each private gateway. Internet gateway is provision, and then we have NAT gateway is still going to be provision. Okay. So here you can see the NAT gateway is going to provision in AP South 1A AZ. Okay. In my case. Okay. Hello.
Yes, you're audible.
Yeah. So so in this scenario, if you see, I have just created a single NAT gateway because when it comes to the cost optimization, there are lots of things comes in the factor based on your use case also. Like let's suppose your requirement is just having a NAT gateway, okay, so that your resources can communicate to outside world. Now you have, let's suppose, if you are running your let's suppose you use the USA region, okay, any of the USA region like North Virginia. So in North Virginia, there are 6 to 7 subnets are there, okay. Now let's suppose you have VPC, which is span across all those 6 to 7 subnets. Sorry, 6 to 7 AGs, okay. And your requirement you want in on a high availability zone. So it's not necessary that you have to create the NAT gateway in each of the availability zone. Okay, it's good to have, but it's a waste of money also because again it depends on the requirement. Okay, so for the multi making a high available, you can have in 2 or 3. Okay, so that way you can save a cost on NAT gateway when it comes to the number of okay. So in this scenario, we were having a 3 subnets. Okay. 3 AGs, and I just have a single NAT gateway. It's not a high availability scenario because let's suppose due to any reason my AP South 1A goes down, my private subnet might so other in other AGs, if something is running, that might get affected. Okay, but in this scenario, because most of the time you will be having a single NAT gateway. Okay, so now let's suppose if I running any of the resources in AP South 1B private subnet. Okay. So the traffic will be going forward. Just give me a minute. Okay. So all the resources are created. Let me show you the route tables. So you see route tables are created. So my network map is look like this. Okay. Yeah. Okay. So you can see this NAT gateway. The NAT gateway which is created it is created in AP South 1A. Okay. Now let's suppose as a now you have to provision a EC2 instance, okay, and you want to provision in a private subnet, and you want to have this to make sure that it is running in like it should be able to access outside the internet. So what you can do, you can, instead of running the same EC2 in 1A, what it helps, that you don't have to pay for inter-AZ data transfer cost. Okay, so there is a cost for the inter-AZ data transfer, and it also, because your resource is running in 1B, okay, and it has to access the internet gateway, but your route table says that the data first have to go to a NAT gateway. Okay, NAT gate. So in this scenario, let's suppose 1C our resource is running, so the route says that the data has to transfer to NAT gateway, which is running in 1A. So first your data is going to 1A. So there is an inter data transfer cost. Then it is going outside the internet. Okay, and same, when the data is receiving also, you have to pay for, because the data is also receiving via the NAT gateway. Okay, so you have to pay for data coming, like whatever the response is coming for your request is also coming in A to C. So you have to pay for the data transfer from A to C and C to A both. Okay, and you also have to pay the data transfer of NAT gateway. So what you can do, you can instead of provisioning in your resources in 1C, you can provision resources in 1A. Okay, so that is one more way. If it talks about, like, if you are in development environment, so you can do in this way. Okay, so there is one, this is one part how you can save the cost. Okay, you got the point, or anyone having any issues or like that? Hello. Looks good to me.
Yeah, doing it.
Good for me.
Yeah.
Now you're saying to create the NAT gateway in the same, same AZ.
Yeah, where your most of the resources are running,
Most of the
you should have the NAT gateway in that AZ, so that you can save the cost. Okay, so that is one factor. Now it also reduces the latency part. How? Because you don't have to, your net data don't have to traverse over the AGs. Okay, the same AZ can be if it is in same AZ, the data latency will be also reduced. Okay, there is not much increment, but if we talk about 1 millisecond, then obviously there is a reduction into that. Okay, now
one more doubt.
Yeah.
Where can I see that cost? Is it visible in AWS Cost Explorer?
yes, you can see in the Cost Explorer, the cost breakdown will be there, like the data is being transferred between which AZ to which AZ. Okay, so you, based on the these stuff, you can check. Okay,
Sure.
and you can use the Resource Explorer to identify where your most of the resources are running, and you can take the decision based on that also. So in AWS there is a service called Resource Explorer, and you can identify all the services in your AWS account based or particular reason. You can have the based on the filter using tags and all. So there you can identify them also. Okay.
Got it. Thank you.
Yeah. Okay, and or there is one more way. You can go to EC2. Like, let's suppose you are in Mumbai region. If I go to EC2, and you can go to network interface, and you can check because this way, this network interface not only provide you the visibility of not just EC2, it will provide you the visibility of any network interface created in your AWS account under this region. Okay, so let's suppose I have the NAT gateway, so NAT gateway ENI is there. If I am having an RDS also, so RDS ka ENI would be coming here. If I am having in Lambda or anything which is attached to my VPC, all the ENIs will come there. Okay, so you can use the availability zone to filter which where your most of the resources are running. Okay. Now, so this is one way you can save the cost. Now, the second part is, so let's suppose your application is communicate with S3 most of the time. Like you are heavily utilizing S3. You are doing some data transfer to or from S3. So you can save the cost and your resources are running in private subnet or public subnet, it doesn't matter. So if you are running resources on EC2, and so what you two have to do, you have to create use endpoint. Okay, do not rely on NAT gateway. Okay, and in endpoint there are two type of endpoints are there. One is interface endpoint. One is wait. Yeah, so there are two types of endpoint. One is the interface type and another is gateway type. Okay, so only two services have the gateway type. Okay, so if I talk about, so there are two type, only two services has the gateway type. One is the DynamoDB and another is S3. Okay, so these two services supports the gateway type. Apart from this, any of the service you want to communicate privately, you have to provision either the interface endpoint. So if I here I'm why I'm talking about S3 and DynamoDB, because when it comes to the gateway type interface, there is no charge for running it. There would be charge for data transfer, but there is no charge for running it. And your data will be going through private network, not through internet gateway and then S3. Okay, so always try to have, if you are any of the resources communicating with S3, have this gateway enable, gateway point enable in your VPC, attach in your VPC properly, and you can save the cost of, like, let's suppose you are, so in my case, so if you see in my case, let's suppose I'm running in 1A. Let's suppose my EC2 is running in 1A or 1B private subnet. Okay, I am running one data analytic service, which is has to download 1 GB of data from S3. So how it's going to through, because it's in private subnet. If I talk about normal scenario, so first of all, my traffic has to traverse through NAT gateway, then internet gateway, and then to S3. Okay, so I have to pay for NAT gateway cost, and then I also have to pay out the outbound cost from the my VPC network. Okay, so these two costs I have to pay. Now, if I, let's suppose, instead of 1A, if I were using 1B and 1C, then I also have to pay for the inter-AZ cost. Okay, so instead of that, what we can do, we can create a endpoint, and that endpoint of S3, if let's suppose AWS service type, and if I do search for S3, so you can see S3 has the two different type of gateway. One is interface and another is gateway. So use gateway. Okay, because gateway won't charge you for running it, but when it comes to interface, there is a charge for running and interface attached to your subnet. Okay, and there is a charge for each subnet you are attaching it to. Okay, so I will be covering that also, how much it's going to charge you for per subnet per AZ. So in our scenario, let's suppose we have 3 private subnets. So here you can see we have the 3 private subnets. So if I'm going with interface endpoint, I have to attach it with 2, 3 subnets. Okay, let me show you. So it will ask me to attach to which subnet I want to attach. Okay, so I have to select all 3 subnets. So if I attach to each 3 subnets, so I am going to charge. I will be getting charged for 3 subnets. Okay. Okay. So
Nitin, one quick question.
Yeah.
Right. May I?
Yes.
Okay. Right. Let's say I have a EC2. By the way, my expertise are in GCP.
Yeah.
The bidding there is a bit different. So excuse if I'm wrong. Yeah. Let's say if you are accessing a service from your compute, let's say EC2 or whatever, to a service which is non-AZ specific. For example, let's say DynamoDB, SQS, or SNS, or maybe even S3 bucket.
Yeah.
Because they are not
AZ
AZ
specific.
specific.
Yes.
As far as I understand, it doesn't really matter, right? The thing is, because they are not AZ specific, the traffic to them from any AZ within the region should be free, right?
No, it's again based on the your routing configuration. Okay,
Oh,
like
okay, okay.
like let's suppose in our scenario, if I show you, we have the private subnet. Okay, private. So
Hmm.
private subnet cannot directly have communication to outside network. So what we do, we place a NAT gateway here. Okay.
Okay.
So all the traffic has to go via the NAT gateway. Okay. So
Hmm.
in route table you can see all the traffic, outside traffic has to go via the NAT gateway. Okay.
Hmm.
And there is a charge for the NAT gateway.
Hmm.
Okay. And charge is based on GB being data out and plus GB data is coming in. Okay.
Hmm.
So NAT gateway charges both.
Hmm.
Now, why should I? And from there, again, because it's leaving my VPC, means my internet gateway, then it's in charge again.
Hmm.
Okay. So to avoid that, in case of S3 and DynamoDB, use gateway type. Okay. So
Okay.
here you see, I choose interface. I have to select the subnets,
Hmm.
and in AWS private link, if I say these things are called private subnet. So
Hmm.
interface endpoint have a charges of per VPC endpoint per AG, which is 0.013. So let's suppose my whole infrastructure is span across 3 AGs. So I have to multiply 3. That is a running charge, not the data transfer charge. Data transfer charge are always remain same in both gateway and AG. But
Okay.
now my data is going through private network because I have a
Okay.
private link between my resource, my VPC, as well as S3. So my data is going via that. Okay. So that's how you can save a running cost of interface for S3 and DynamoDB.
Hmm.
Got it?
Yeah. Thank you, sir. Thank you.
Yeah.
I got confused that because it's within the same region.
Yeah, but there is a data transfer when if anything, any byte is leaving your
Oh,
internet
this is
gateway.
because of the private subnet, right? Yeah. Okay. Yeah. Okay. Got it.
Okay.
Thank you.
Yeah.
And if I may add, Nitin, one point here for
Yes.
Guru. So, though the cost optimization session is going on, right?
Yes.
But leaving traffic, so the traffic when it is leaving your VPC and then going to S3, it actually is traveling through internet, right?
No,
So it's a big security concern as well.
yeah. When it comes to directly traffic, routing your traffic via internet gateway instead of using private links. Yes.
So when
That
you are
is-
using S3 endpoints, like a gateway or interface, anything, your traffic is completely secure within the cloud network itself. It's
Yeah.
traveling on the AWS backbone.
Yes, and again, it's reduced the latency because it's in the same network
Exactly.
of AWS. Okay, so you can use the S3 if you are your resources are using DynamoDB. Use the DynamoDB gateway. Okay, so here you can see in S3 I select gateway this time, but this time it just letting me know which route tables I have to attach it. There is nothing I have to tell like which subnet and all, and there is no charge for using gateway. Okay, and I have written one blog for the same. I will be sharing here so that you guys can follow. Like when to use which service. Okay, just give me a minute. So I've shared in the group. Okay, so others also can view it later point in time. Okay, now so this is about VPC, like when to use like you can reduce in S3 or data transfer as well as in the DynamoDB. Okay, for other services again it depends on your requirement. Okay, now as someone mentioned that again if you are okay with moving move your traffic via NatGate, via the public network, then again, let's suppose you have to communicate 5 services: SQS, SNS. I'm just taking a random services: SQS, SNS, then any of those AWS services. So you don't have to provision the endpoint for each. Okay, so the same stuff will cover that. Okay, like when to use. Like let's suppose if you are just talking to AWS services, nothing more than that. and you are going to top only 4 services, then create the interface VPC endpoint. Okay, but if it is more than that, use NAT gateway, because there is again running cost of each interface you are going to create. Okay. Hello.
Yes, you're audible, Nitin.
Yeah, you're audible. Continue.
You got the point here. Why, like whatever.
Yeah.
Okay.
Continue.
Now, so this is one point. Now let's suppose we have 2 VPCs. Okay. So one VPC is this one, and let's suppose I am having one more VPC, project 2. Okay. And now I want you to, I want these 2 VPCs to communicate each other, because due to any reason, it's up to the requirement. Like my requirement is like we have one VPC where project A is running and project B is running in project 2 VPC, and there is one API which needs to be communicated privately. Okay, so now to connect 2 VPCs, there are 2 different stuff to connect 2 VPCs. Okay, so they can communicate privately. One is using the VPC peering, and another is using transit gateway. Okay, so what you can do, because the data transfer rate is always same for most of the AWS services when it comes to the data transfer between, like if I talk about data transfer cost between 2 VPCs, it remains same either let it via transit gateway or let it via the peering connection, that remains same. But now you have to save the cost of running. Okay, so if I come to 2 VPC, so yeah, so let's suppose, so we have these 4 VPCs in here. Okay, so what we can do, instead of having a transit gateway again, okay, what we can do, we can do a cross connection of VPC here using the VPC peering. Now it will create one overhead, the overhead of maintenance. Okay, if you are okay with that, or maintenance means it's a one time, it's up to you, like the maintenance is of a one time or continuous maintenance it is, like you have to modify again and again. Okay, and how many VPCs you are going to connect. Let's suppose if I am having a 4 or 5 VPCs, I would prefer VPC peering, because VPC peering running cost is 0, but using a transit gateway and connect them, and then there is a cost of running of transit gateway. Okay, got it. Now again, let's suppose my number of VPCs are 200, and I want all of them to connect to each other, then it's very hard to manage using the VPC peering. At that case, you can opt in for the transit gateway, because having a 200 VPC and making them connect to each other, it's like a permutation computation of like that is a very big number, the number of connection being created. Hello.
Yeah, continue. We are listening.
So you got my point here.
Quick question, Nitin. Rather than connecting with each other, that will create a mesh, correct?
Yes. Yes.
Yeah. Why can't we use the spoke and hub model?
Using transit gateway again, you are saying.
Yeah.
Yeah, that you can use. Again, it's depend. Like in my scenario, because it's a development environment, let's suppose.
Okay.
So you don't need to have a transit gateway and have a communication. Okay, but let's suppose if you have the VPN, if you have a corporate connection, then obviously you already having a transit gateway and you can attach your VPC directly. So again, it's up to how you want to manage. Are you okay with overhead of maintenance, one-time maintenance, or are you okay with cost? Okay, it's the both you have to consider, and it depends on the number of VPCs. Let's suppose it's a 2 or 3 VPCs, then the maintenance won't be there also. Okay, but running on of a cost of like I have to pay a $36 for a transit gateway if I talk about a baseline. So, and this is a recurring cost, the monthly cost. Okay, even I use it or not, it doesn't matter, but I have to pay a $36 every month. You got the point? Hello.
Yes.
Yeah. We're listening.
So, yeah.
If
So
your
it's
voice goes away, we will let you know. Don't worry. You continue.
Sure. So this is how you can save a few of the cost when it comes to by using the service. Okay. So each of your decision depends on your actual requirement also. Like let's suppose if you want to have the secure connectivity, then obviously you have to choose the private link. But if there is none kind of concerns, so these kind of situation you can opt in for. Okay. Now I will show you one more place where how you can save the cost. So let's suppose I am having a load balancer. Okay. So I'm going to have one network load balancer. Okay. So wait just a second. Just,
Then you can close the pop-up, it won't go away. So definitely, yeah.
yeah. So let's suppose we have a load balancer. Okay. So I'm in the load balancer balance attributes here. Okay. Now in the load balancer, you can see like I'm having a load balancer, and my current configuration says I have span the load balance, like the load balancer is created across. In my case, I have 2 AGs, but I'm just giving in a scenario here that it's a 3 AG load balancer. Okay. So now let's suppose the traffic, okay, whatever the traffic coming to AZ1 is going to AZ1 resource only. Okay, if I'm having a resource running in AZ1, okay, else it will get dropped. Okay, in this scenario. Okay, same goes for the data AZ2 to AZ2 resource, same AZ3 to AZ3 resource. Okay, now if I enable cross AZ, so what will happen if my packet coming on AZ1, it can distribute traffic on AZ1, AZ2, AZ3. It based on, again, based on the configuration, you have the route robin or whatever. Okay, so it will distribute across. So again, there is a data transfer cost of here. Okay, and in case of network load balancer, there is a problem with that also. If you deal with the TCP directly, okay, TCP connection directly. So what will happen if you enable this cross AZ? One is the cost, another is the port issue. So one port issue is it will, so as you know, like whenever a connection made, it will open up ephemeral ports. Okay. Hello. Hello.
Yes, you're audible.
Yes, yes, you're audible.
Yeah. So if you enable so as soon as the TCP connection is get created, it will open a ephemeral port, because NLB is nothing but a resource running, but it managed by AWS. So it will open a ephemeral port on their service as well, and then it will create a connection to our resources as well. So if you have the if your connection crosses a particular threshold, so then there is a chances of the TCP connection actually the ephemeral ports conflict will come. Okay, so there is a problem with that. I will share. I have written one blog on that. I will share that also because this is cost of prevention. So I will just cover the cost of prevention. That particular problem I will share over the group. Okay, so if you enable this cross AZ, again, let's suppose you are in development, so and you enable the cross AZ. So your development data like you have to pay for the data this cross AZ, because your data land on AZ1 and it going to AZ2, same AZ2 to AZ3 or whatever. Okay, so you can disable the cross AZ in case of your development environment. Okay, so this is one place you can save the cost. Hello.
Got it.
Yes.
Yeah, and now, so any of you have used EKS? Hello.
Yes, I have.
Yes.
Yeah.
Yes, we have used the EKS.
Yeah, I will cover that part also, because there is a so you obviously with the EKS you have used ALB or NLB, whatever, using AWS AWS load balancer controller. Yeah. So when you create a AWS load balancer controller and you launch on load balancer, so most of the time what your target group alike, it's a target type of instance or IP.
I think it's IP.
By default, actually, it's an instance until unless you specify IP. Okay, when it comes to provisioning through ALB controller. So in ALB, yeah. So by default, if you launch it with this IP, because if you did not specify the type, target type, it's an instance type. Okay, default type is an instance type. So now let's suppose you have an EKS cluster. Okay, and so let's suppose you have one EKS cluster. Okay, the EKS cluster has, let's suppose, 3 nodes. Okay, and each of the node is running in each AZ. Okay, like each AZ, AZ1, AZ2, and AZ3. Okay, and you have the single pod. Let's suppose. Okay, my scenario is, I'm just covering the scenario where you have a single pod. Okay, and what the ingress actually do, it will create a it will open a port, a formal port on your server, and it bind your instance using target group instance type, and then so what it will do, it will the load balancer will send the traffic to your instance, any of the instances it can send, and from there your Kubernetes service will send the traffic to respective pod. Okay, so instead of doing that, because it will, what it will do, it will increase the number of hops in your traffic. Okay, because let's suppose my pod is running on instance 3, which is running in AZ3. Okay, but my because due to round robin algorithm, my traffic reaches to instance A first, and from there it is reaching to instance 3. So we can reduce this hop by using the target type of IP. Okay, so so you have, in your ingress you have to specify target type to IP. Okay, so that way you can reduce the number of hop, as well as you can reduce the cost of data transfer. Okay, because the data which is lands in might be in AZ3, but due to round robin algorithm, it is going to AZ1, where even your pod is not running, and then it is coming back to your AZ3, where your pod is running, or AZ2, whatever. Hello.
Can you elaborate it, listen? Once again.
Yeah. So let me. Okay. So in AWS, if you provision EKS, okay, and so if you provision an EKS and you are running any service on the EKS, okay, so on that, and if you are using AWS ingress controller, AWS AL load balancer controller actually. So when you provision an ingress, okay, so the ingress is going to create an ALB, okay. If it is service, then it is going to create an NLB, okay. If you are going to create a load balancer type, okay. Now by default, the target group which is going to be created is the instance type, okay. So whatever the number of instances you are running in your EKS, let's suppose 5, 10, whatever number of instances you are running, all the instances which is in your that particular auto scaling group will be get added into this target group. Okay, it doesn't matter your pod is running on which EC2. All of the instances are going to add in this target group. So the target group you are going to create will be going to create using that ingress you have created using load balancer. Okay. Now, let's suppose I created one load balancer and I attach that, let's suppose an ALB I created and internet facing, or, yeah, or whatever. Okay, so it will be sending you, let's suppose I'm having 3. I'm not going to create instances, but I'm just showing you through the load balancer. Okay. If you still having any query, I'm happy to help you. Like I'm happy with the query. Just give me a minute. Okay. Okay. So I created another load balancer for ALB type. Okay. And I attach in, so it would be the similar scenario how your system is going to provision. One ALB it is going to create, one target group it is going to create. And because it's an instance type, it will add all of your nodes, okay, which you have mentioned, which you have in EKS based on the auto scaling group. It will add all of them into this particular target group. Okay, let's suppose if you have 20 nodes, all the 20 nodes will be coming here. Okay, and they will get registered. And let's suppose your in scenario like you have 20 nodes, but your deployments have 3 pods only, because there are lots of deployment is happening, but the deployment which I'm talking about having is deployed across 3 nodes only. Okay, it could be in multi-AZ, it could be in whatever. Okay, now ALB default, how the ALB is going to distribute the traffic, it's using the route robin algorithm. Means it will be going to send the traffic to node 1, node 2, node 3, node 4, node 5, whatever. Okay, now your pod is running on 3 nodes only. Okay, so let's suppose the 4th node, which is not running your pod, will serve the traffic. How? It will send the data to your Kubernetes service, and Kubernetes service will check, okay, pod is not running here, send it to this particular pod node or whatever. Then it will send the data back to the pod, which is the node which is running your pod. Okay, and that's how it will serve. But it will increase the number of hop, because your data has to reach all the nodes. Then the most means out of 20, only 3 times it will be reaching to the correct node. If I'm talking where the your EKS cluster has the 20 nodes and your pod is deployed on 3 nodes only. Okay, so the hops you can reduce here, and if you use the IP type service, you can directly contact with the pod. Okay, so the latency will reduce.
So you mean to say the service endpoints?
Yes.
Yeah, okay, good. So you mean to say the service endpoints of the 3 pods, those
Yes.
IP will be
Automatically
in the
get
target
added.
group, is it?
Yeah, will use the IP of those pods only instead of instance type. That's what I'm saying. Yeah, you're correct, Ismail.
So I have one question, Nitin, basically. So far the explanation has been really good. Okay, and thanks for that. So what I'm trying to understand is when the pods, like for example, if it's a daemon set pod, right, and it is deployed across three different nodes across three different availability zones, right? In that case, also when you have a service associated to the three pods, right, and in that case also, so basically the request goes to the service first, and then the service also decides which pod it should go to, right?
No, that what I'm saying. If you use IP type, it won't because in AWS how they do. So it does. If I talk about generally Kubernetes, so whenever you are running a Kubernetes cluster, so actually, if you create a deployment and you attach to a service, what it will do, it will open your service on a particular ephemeral port of your host machine. Okay.
Okay.
So if you directly call your that ephemeral port now, it won't go to the service. It will directly go to your pod. Okay. So
But
you
which
can
pod will it go to? Pod 1, pod 2, pod 3? Which one?
again, it depends on the host you called. If the service is present on that, again your call again, it depends on your Kubernetes service configuration. If it says that same, if I'm hitting the same server and the pod is present there, call it. Or again, if the service is configured in the round robin fashion, it will go to other server also. So it depends
And
on
it
your
depends on
configuration.
your pod count as well. For example, if it's a single pod,
Then
yes,
it will obviously go to that
that
particular-
pod, but in the most optimized position, if your service or your load balancer which it's pointing to goes to the same node where your pod is, the service is, then no problem.
Yeah.
But let's say you have three pods, yeah, then if we go through an instance target group, what it will do is send to the service then may have to send the traffic to three different things,
Yes.
which may be a couple of more than one hop.
Yeah.
As Nitin mentioned. But
Yes.
if you use that IP, what we do is it will literally do what we call a neg, I think so, in GCP terms, where the ALB will be literally pointing to the pod IP rather than directly going through a service which then does a hop.
Yes, that's correct, Guru. It will be following the same concept.
Yeah.
So
Does
it
this
will-
make sense to you, madam?
Yeah, it kind of, but I think I have to read a little bit more.
You have
What
to.
we can do, we can have a practical session in upcoming days where
Uh-huh.
I will show you the difference between these two services, like in
but-
these two scenarios.
Yes.
Nitin, if you're going to do that, if there is cost associated, let me know. I
Sure.
will bear some of your costs.
Sure. Thanks, Guru.
Same here, Nitin.
Hi, Nitin.
Yeah. Hi.
So how I summarize it is like we are just saying to the load balancer that they should not follow the round robin algorithm. Rather, they should just point out to the IP addresses of the nodes, and that's how we are saving the hops. And is it like how I'm understanding?
If you miss the round robin part, no, round robin will still be there, but instead of pointing to all nodes in your infrastructure, because in our scenario, if I consider 20 nodes, so if it is an instance type, it will be round robining across the instances. But if it is an IP type, then it's round robin across 3 IPs only, where your service is running. Okay, so it would be round robin only, but we will be directly pointing to the pod instead of pointing to the node and then the pod.
So the number of hops will be less.
Yes.
And then if the hops is between two different availability zone, then there is a cost. But if
Yes.
that's what it is. So means, as it says, if I want to go to my kitchen, I should go to my kitchen directly rather than going out of the house and then coming back.
Yeah, it's kind of.
Yeah. Sorry, I'm a foodie, so.
No, that's a very good
Yeah,
example.
just one thing. So you mean to say if we are using IP address instead of instance, so IP address type, so my traffic directly goes and check where my pod is running. So it will
Yes.
basically pointing to the pod on
Directly.
which node it is running. So directly it will call to exact pod. That it means we will save number of hops in this.
Yes. Yes,
Correct.
2 to 3, like minimum 2 hops you can save via this.
Yes.
But
Manjusha has a question. Yeah, go ahead.
Yeah. So, excuse my ignorance, but see, then the whole point of having a service is gone, right? If you have to associate with the pod IP again, right?
No, because only the service will tell the load balancer what is the IP of the pod, right?
Yes.
Hence, ALB will not know what is the IP of the
Yeah,
pod.
that's
Right.
true,
So
because
what if that pod goes down, right? And what if that pod goes
Then it
down?
will automatically advise the service. Service will then tell the load balancer where to point to.
Yeah, so obviously the pod downs, Kubernetes will provision new and it will attach to service, and the Kubernetes webhook
Service
will tell
the
load
LB
balancer new
where to
IP is there, and it will update into the target group.
As they say,
But
it's the target.
Nitin and Guru, the thing is, with respect to ALP, there is some draining period which will delay this process. Whereas with respect to Kubernetes service, it is instant. So in this case,
You can
No,
you can
because it's a
configure
target
them.
group, it will automatically do that. There will be, by that time, if there is a delay, it will be so minimalistic, because unless it is up and running,
Guru,
and if it's running, it will not go through.
Guru, actually, it depends on the requirement to requirement. Because in my case, we were needing, let's suppose I want to terminate a pod, we were needing time, because that pod has to, because let's suppose it's an auto scaling group, and my pod is in horizontal auto scaling. So let's suppose initially I have a three pod is running, and due to number of load, my number of pods is increasing. So I have to scale down. So at that time, I cannot directly terminate the pod. First of all, I have to deregister in the target group and then remove the pod. So all this can be configured via the AWS control, AWS load balancer controller Helm chart.
Yeah.
Okay, so we can configure all those deregistration, delay, and the pod termination, because sometimes it might possible that pod get immediately terminated due to any of the reason, like crash back loop or memory exhaustion or whatever.
OOM also is possible.
So these scenarios might be possible, but yeah, we can reduce them based on tweaking our configuration of the load the controllers and services.
The thing is, remember, guys, people who have worked on Kubernetes for a long time, it's a bit obvious. If you are kind of new, less than 3 to 5 years experience, you need to see it.
Yeah,
that's what it is. You need to have a practical session, which we will be happy if Nitin.
Yeah, I'm very happy, because generally what I see when it's come to, because I have an experience of 9 years in the DevOps industry. So what I see, like when it comes to the as a newcomer, so you generally follow when it comes to the Kubernetes specs, you follow 4 to 5 things only. Like you mentioned images, just mentioned the ports, it has to be exposed, or just configures, but you don't follow other parameters of it. Okay, then you start following affinity, anti-affinity. Then there are lots of parameters which make it much more stable comparatively. Like just having these parameters, there are a lot of parameters when specifications comes to each pod deployment or any type of definition. If we talk about, or API we talk about in Kubernetes, so we should start tweaking them and understand how each tweak will change the behavior of each pod or service or the API.
And remember, some of them are also dependent on the cloud as well.
Yeah.
For example, in GCP, the cost between any availability zone within the same region is minimalistic.
Yes.
Yeah, comparatively region to region.
Yeah, exactly.
Same with other cloud provider also.
Yeah, exactly. So as Nitin mentioned, right, it all depends. It's all about reading the manuals and making sure that you do what you think. Just don't go and blindly provision it using a Terraform or a GUI without understanding the implications. Correct, Mr. Nitin?
Yeah, that's very true. Like we should know in out and their cons, pros, because
and if you don't know, ask Nitin Goyal. That's it.
Yeah, you can anytime you can ping me in the group, and I will be very happy to help. Okay, so I guess we can. Does anyone having any other question?
No.
Sure. What I will do, I will try to arrange one practical session in the upcoming days, and there will be understanding this Kubernetes part, because I know lots of confusion is still there. How we can save the hopes and all. We'll be having one practical session on that Kubernetes part. Okay. And infrastructure wise, is infrastructure cost related part. Okay.
Okay.
Sure.
Thank you, sir. Thank
Thank
very
you.
much.
Thank you. I will be sharing this recording with everyone in the group. Okay. Thank you, everyone. Thank you.
Thank you.
Thank you.
Bye.
Thank you,
Thanks
Nitin.
a lot,
Thanks,
Nitin.
Nitin.
Thank you so much.
Thank you.
Really helpful.
Thank you, everyone.
Thank you, Nitin.